Do you drink water, own a cell phone, or use a computer? Well, then listen up because I'm about to tell you about the biggest scientific discovery in recent times. I'm Sebastian Harmon, and today we are looking at graphene. What is graphene, you might ask? Well, I'm glad that you asked that question. Graphene is a hexagonal lattice of carbon atoms in a honeycomb pattern, only one atom thick. It is the world's first 2D object, making it the thinnest object that we have ever isolated. And I have a visual aid. That right there is the honeycomb pattern of carbon when it's in the form of graphene. When was graphene discovered? Well, Jan Theodor Janssen tells us that in 2014, graphene was first discovered by two scientists from Manchester University, Konstantin Novoselov and Andrei Geim, in 2004. 2004 is when it was discovered. 2014 is when this article was written about it. Both Konstantin and Andrei won the Nobel Prize for Physics in 2010. How was graphene discovered, or how was it made? Well, they were actually cleaning up chunks of graphite with pieces of sticky tape to give it an even surface, and they noticed thin pieces sticking to the tape as they were removing layers. So then they started using other pieces of sticky tape to remove more and more layers, and then more and more layers, kind of switching it back, like if you were to take a cup full of water and pour it into cups and then keep pouring it into more cups until you just have one drop in each cup. That's basically what they did. And they came up with a material that was one atom thick, or about as thin as Donald Trump's chances of making it to the White House. So what makes graphene so special, right? Is it just thin carbon? Because we know that carbon is essential for life, but we have a lot of different materials that are better suited for a lot of things. Well, graphene is super thin, as I've already said. Human hair is 1 million times thicker than it. But graphene is also super strong. It is 200 times stronger than steel per tensile strength, so stretching it. It's also transparent, or almost transparent. It only absorbs 2.3% of light, and it absorbs light across the spectrum, not just visible light, but also infrared light, ultraviolet light, things like that. It has better conductivity than silver, and because of this, graphene is actually the most conductive material in the world that we have discovered so far. And it would basically be impossible to be more conductive than graphene due to various chemical properties that it has. It is also the perfect barrier. It is impenetrable by any gas or liquid that we have discovered so far, including helium, which is one of the smallest atoms on the table of elements that we've found. So with all these different with all these different properties, what are some uses for graphene that we might have? Well, a big one would be water filters. Clean water is a problem all across the country, or all across the globe. Especially in Africa and other third world countries or underdeveloped countries. In a 2015 article from Advances in Processes, a scientific journal, we were told for faster, longer lasting water filters, some scientists are looking at graphene to serve as ultra-thin membranes, filtering contaminants quickly from large quantities of water. So imagine having a filter the size of a bottle cap, and actually built into a bottle cap, that you can fill a water bottle with however dirty water you need to. Just fill or put the cap back on and then drink it, and it's filtered by the time it reaches your mouth. That would be huge for people who are poor. It would help a lot for places like Flint, where they have water quality control problems. And because it's right at the source, so you could attach it to the filter, or to the faucet. You attach the filter to the faucet and just have clean water, no matter what sort of contaminants are in there. Obviously, with it being the world's most conductive material, and also incredibly strong yet flexible, you could use it for a wide array of electronics. And this is where I was talking about the cell phone and computer. Mark Peplow, in a 2013 article, tells us that graphene conducts electricity faster at room temperature than any known material, and it can convert light of any wavelength into an electric current. This is literally a wonder material because we could have solar panels that, instead of having to have photovoltaic cells on them, we could literally just have them lined with graphene and have the graphene converting the energy or the sunlight directly into an electric current. This could potentially eliminate fossil fuels entirely from our production of electricity. You could use it in cell phones to make really flexible, bendable cell phones. It doesn't matter. You can break them, you could drop them, and it wouldn't matter. You could make laptops that are much lighter. You could put them in your backpack. You wouldn't feel anything, and they'd just be much more durable and faster as well. Another place that you could use graphene is in clothes, such as wearable electronics, which we're already experimenting with some now. But say a shirt that tracks how many calories you burned, and you just put it on. You don't have to wear a bracelet or anything like that, but your shirt will track it for you, or it tracks your heart rate, how far you ran, things like that. Also, with it being so strong and yet pliable, a big, like an easy thing to do with that would be to make it into bulletproof vests or protective gear, such as motorcycle clothing, like motorcycle jackets. Also, graphene would be a huge addition to lightweight structural components. Everybody's trying to make the lightest cars that they can, while also being safe and being strong and durable. If we had graphene to use in body components, pieces of the frame of the car itself, we could easily eliminate hundreds, if not thousands, of pounds of excess metal and just make cars that are lighter. You could push them if they're broken down, and cars that are safer because they'd be stronger. Same thing goes for boats, like making a kayak primarily out of graphene means that you could portage it wherever you wanted to. You could have a whole kayak and it maybe weigh 3 pounds. You could have a motorcycle that you could drag up the stairs when you're going to your apartment or whatever. It doesn't matter because with graphene it'd be incredibly light. With all these huge benefits of graphene, of course, the reason why we aren't using it as much right now is because of problems with production. The sticky tape method is, while it's very simple, it's not easy because it requires a lot of time to produce any large quantity of graphene, and even when you do, they're in little flakes, so you can't just piece it together. And so this actually makes it one of the world's most expensive products of any kind, because it can cost up to $1,000 to make micrometers worth of graphene. So that's just not very cost effective at all. Another process that scientists are looking at is forcing methane across a large copper filament that is heated up to 1,000 degrees Celsius, and this would deposit carbon or graphene in a single atom all across the carbon filament, or the copper filament, excuse me, and then they could just go and remove that that way. By 2020, this industry is going to be worth $250 million, or around $274 million to be exact. So, with the way that things are looking for graphene, there's very few things in life that are certain, but I think Trump whining about a rigged election and graphene being important, hugely important in the future of humanity, they both seem like safe bets to me.